Okay, so example 5, we want to solve this equation. It's kind of similar to the last one that we did. What I would recommend doing is, even though this is equal to 0, I would notice this is not a perfect square. So there's two approaches you can take here, and I'll kind of walk you through both. So option number 1 is you can actually factor this. So you can say this is the difference of squares. I realize this is not a square, but I'll show you. And you can approach this as 2 cosine x minus square root 3, 2 cosine x plus square root 3 equal to 0. And you can use the zero product property like we did on the last example. Now, you don't have to do that. I don't know that that's completely obvious. I'll finish us out with the second type, or the second option, and that's where you use the square root property. Okay, and that's where you take your 4 cosine squared x minus 3 equals 0, and you move this 3 to the other side. And you actually would divide by 4 as well. So you've got cosine squared x is 3/4. And then what you're going to do is you're going to take the square root of both sides. Okay, so on the left, that gives us just cosine x. On the right, because we introduced the square root, we've got plus or minus square root 3 over square root 4, which means we've got cosine x is plus or minus square root 3 over 2, okay? So this is the one I'm going to operate off of. If you chose to do the difference of squares, you would actually end up with the same exact answers. So it's totally up to you how you proceed. So this is really the equation that we're looking at now. Let me write it off to the side over here. Cosine, well, I guess I don't have to. This is really the equation that we're looking at here. So if I bring back our unit circle, let's put it on this left side this time, okay? We're looking at two kind of pieces of this, right? We're looking at one, where is cosine of x equal to a positive root 3 over 2? Where is cosine x equal to a negative root 3 over 2? Those are the two kind of pieces we're looking at. So let's do the positive one first, and I'm going to do this in blue just so we have some reference for it. So again, I treat this as in my first quadrant, in my first quadrant, right, I'm going to treat this as a reference angle. Where is cosine equal to root 3 over 2? Well, cosine is our first value, right? I know we run into pi over 6 pretty often, but we're going to use pi over 6. So we've got this value right here, right? And this is our angle. Theta is pi over 6. And we'll kind of double dip and treat that as a reference angle as well, right? So the other place where cosine is positive, because this is positive, that's this first group we're looking at, the other place where cosine is positive is down here in the fourth quadrant. So remember, the rule for that is our other angle is going to be equal to 2 pi minus the reference angle. And this is going to double dip as a reference angle. I guess if you really want, you could call this something else like alpha or something, but it's just our secondary angle. So that means we're looking at 2 pi minus pi over 6, or 12 pi over 6. That's just this with 6 in the denominator, right? Minus pi over 6, and that's 11 pi over 6 right here, okay? So our second location for that is here. Okay, so the two angles we get from this are 1, x is equal to pi over 6 plus 2 pi n, and 2, x is equal to 11 pi over 6 plus 2 pi n. For some n, that's an integer. Now we want to do something really similar. Here, let's go with like a pink this time, just because we can. So over here now we're looking at another, a similar question, but it's negative this time, right? So we go back again, we think about in terms of inverse cosine functions. Well, cosine inverse is going to live, cosine inverse is quadrant 1 or quadrant 2, right? You remember that cosine is one of the different ones in that case. So quadrant 1, we're positive. Our negative value won't show up here. It must show up in the second quadrant where cosine is negative. So we see, and again, I can use reference angle notation to make this work. And it's really the same reference angle as this, right? Remember, reference angles always give us positive outputs. But if we were to put cosine in the second quadrant, so then we would say theta is pi this time, because that's the rule. Come on, pen, right? Pi, there we go. Because that's the rule for the second quadrant, minus our reference angle. There we go. Our reference angle, which is theta, is pi minus pi over 6. And I think we've done this one a few times now. That's 5 pi over 6. So that's right here. And you can even visually see on a unit circle, right? There you go. That's that cosine is negative root 3 over 2. We do something really similar because the other place that cosine is negative, and let me write my answer down before I forget, is 5 pi over 6 plus 2 pi n. The other place cosine is negative, overall, not inverse, but cosine is negative, is in quadrant 3. So to get our reference angle, or to get to our angle from the reference angle in quadrant 3, we're looking at pi plus this time, so that theta is pi plus pi over 6, which when you add those together, you get 7 pi over 6. And you can see that right here. There's your negative 3 pi, root 3 over 2, and there's this right here. Okay, so we were able to come up with 4 answers so far. X is equal to 7 pi over 6 plus 2 pi n. So actually, between the blue and between the pink, we touched on every single time cosine is root 3 over 2, whether it was positive on the right side in blue or negative on the left side with the pinkish color. So again, still same n is a part of z. I mean, you can mention it again. I don't think you absolutely have to, because we kind of already said it once. But you can add it a second time if you want. So this gives us 4 answers. So now this is where we go back and we check our original question. Do we see that there's no interval, right? There's no interval or inequality if you want. But what this means is there's no domain restriction. Or even, I can say that a little better, no restriction on. What this means is there's no restriction on x. So this is where we use a general solution. So I would take these 4 answers that we have, and to write out what all of our answers actually are. So the general solutions, I'm not limited to 0 to 2 pi, we just have 4 of them. So first up, x is equal to pi over 6 plus 2 pi n. I'm going to put them in order, so I'm going to call this 2, 3, and 4, just so I'm going around my unit circle. It's not mandatory, but it's helpful for organizing. 5 pi over 6 plus 2 pi n. 7 pi over 6 plus 2 pi n and 11 pi over 6. And then somewhere in there, noting again, n is an integer. And these are all our answers in this case. We don't need to break this down using n is 0, n is 1, because these are general solutions, right? If you remember, we only use n is equal to 0, 1, and so on if there's an interval or inequality. Okay, so this here is your final answer. All right, see you for the next question.